Okay, let's finish section 3.5. We've already gone over the first 4 examples. Before I go into example 5, I want to talk about orders of magnitude. Okay. So when I'm comparing 2 quantities, they're going to have you do some problems comparing quantities, and they want you to put it in either scientific notation or powers of 10. So one example is a kilometer and we want to compare that to a meter. A kilometer is 10 to the 3rd power, whereas a meter is 10 to the 0 power. So if I'm comparing these two, write it as a fraction, I have 10 to the 3 over 10 to the 0. So my magnitude here, a kilometer is 3 orders of magnitude longer than a meter. So the difference in my exponents is 3. So it is 3, a magnitude of 3 larger. Okay. Let's do $1. Example 2. So we're going to compare $1 and a penny. Okay, so $1, if I'm talking about quantities, a penny, let's say this is 1 cent. So this again would be like 10 to the 0 power. And $1 is like 100 pennies. So this would be like 10 to the 2nd power. So if I compare those, I'd have 10 to the 2 over 10 to the 0. And so $1 is a magnitude 2 larger than a penny. Okay, that's orders of magnitude. Now let's go on to example 5. And example 5 is comparing earthquake intensities. And we talk about the Richter scale. So, example 5. Comparing earthquake intensities. So they give you this formula for how they calculate what magnitude something is on the Richter scale. And the formula is R equals log A over T plus B. Okay? And these variables, the A is your amplitude. A is amplitude. The T is the period associated with the earthquake, so the period of the earthquake. And your B is basically the distance from the epicenter. The epicenter is where the earthquake originates. Okay. So let's actually do a problem. It wants you to know how many times more severe is a magnitude 7.9 on the Richter scale than a 5.9. Okay, so we're going to calculate how many times more severe is a 7.9 than a 5.9. Okay, so let's go through and we're going to use the formula to calculate this. So our R1, our first magnitude, would be equal to log a1 over t plus b, and our first magnitude is 7.9. Our second one, so we'll call it R2, is equal to log, this time it would be a2 over t plus b, and that is 5.9. Okay? Now, we wanted to compare these two, so I wanted to write it as a fraction. But we need to use the properties of logarithms when we're writing something as a fraction. So when we have a division problem, we subtract the two quantities. So let me switch papers here so I have more room. And so the way we're going to write it is log a1 over t plus b subtract log a2 over t plus b, and that will equal our 7.9 subtract 5.9.